Hello grade 11s and matrics. In this lesson I'm going to focus on the properties of vectors. We'll also be looking at how to represent vectors in a head to tail diagram. Let's go. So looking at properties of vectors, we know that vectors are physical quantities that have magnitude or size and direction. So when we look at equal vectors, what we mean by that is vectors are equal when they have the same magnitude and the same direction. If they only have the same magnitude but their direction differs, they're not equal vectors. If they have the same direction and their magnitude differs, they are not equal vectors. So in this case, A and B have the same magnitude, same direction, so they are equal vectors. Negative vectors have the same magnitude, so the same size, but opposite directions. So an example would be going 50 meters east and going 50 meters west. Those are negative vectors. If we choose east as our positive direction, then our 50 meters west would be our negative vector. It's the same magnitude but going in the opposite direction. Addition of vectors in the same direction. So if we have vectors going in the same direction, we can add these together. So what I do is we see that vector A is 7 newtons. Remember, newtons is a force vector. So someone pushing a box with 7 newtons to the right, and then same person, different person maybe pushing the same box with 3 newtons to the right. Same direction, same magnitude, so I can add them. If I choose the right as my positive direction, remember in physics you always need to choose a direction as positive, then I can add my vectors. So 7 plus 3 is 10 newtons to the right. 10 newtons to the right. That is what I would call my resultant vector, which we're getting to in a second. Then, we're speaking about vectors in one direction here. If I'm talking about a vector that's going in the opposite direction, then I subtract them. Let's look at this example. Let's say vector A has a magnitude of 4 newtons to the right. You can see it's pointing to the right. And vector B has a magnitude of 1 newton and a direction to the left. You can see it's pointing to the left. If I choose, so over here we're using 7 and 3, let's just ignore that for a second. Let's say I choose the right as my positive direction. So to the right is positive. This is arbitrary. What I mean by that is you can choose the left as positive. You'll get the same answer. So let's say I choose to the right as my positive direction. My 4 is going to the right, so it's a positive 4. Then I'm adding my other vector, but it's going to the left, which is my negative direction. So I'm adding a negative 1. And we know 4 plus minus 1 is the same thing as saying 4 minus 1. So I'm getting 3 newtons, positive 3, which means it's going to the right. You can think about this logically if you want to exclude the vector addition calculation for now. And you can think, if I'm pushing with 4 newtons to the right, and my friend is pushing the same box at the same time with 1 newton to the left, overall, there's a resultant force of 3 newtons to the right. Because the 4 newtons, the 1 newton, it cancels out a little bit. I hope that makes sense. Now, what do I mean by resultant? So a resultant vector is a single vector having the same effect as 2 or more vectors together, added together. And we always find the resultant by vector addition. We can use the head to tail method. So here I've got an example. And what I'm going to do is I'm going to redo this example so you can really see what I'm talking about here. I have vector A going to the right. So let's pretend, again, I'm going to stick with forces. Someone is pushing a box with 5 newtons to the right. Someone is pushing that same box with 3 newtons, but upwards. I know it's a bit weird to visualize in real life. So we've got 5 newtons to the right, 3 newtons upwards. Think about it. To the right and up. To the right and up. The same thing. So the resultant, the overall, would be a vector that goes like this. To the right and up. So it's a combination of the to the right and the up would be to the right and up. I hope that makes sense. Essentially, we use the head to tail method. So if you see vector A over here, it's going to the right. This is the tail. of vector A. This is the head of vector A. Then I join the next vector, the tail, to the head. So you can see here, it's the head of vector A and the tail of vector B. Right, so it's head to tail, not tail to tail, not head to head. Head of vector A to tail of vector B. And then the resultant goes from the tail of the first to the head of the last. It's on my next slide. Tail of the first with the head of the last vector. So what I mean by that, let's take a look at these vectors in one dimension. Vector A is going to the right. Vector B is also going to the right. Do you see how we join head to tail? Head to tail when we're joining our individual vectors. Then to find the resultant vector, I go from the tail of the first to the head of the last. One more example. Vector A is going to the right. There's the head. It's joined with the tail of the next vector. Then vector C is going to the left. It's head to tail. The tail of vector C and the head of vector B, but it's going in the opposite direction. And then the resultant goes from the tail of the first and points towards the head of the last. So you can see the resultant vectors going like that. I hope this makes sense. In the next video, I'm going to be going over some simple vectors in one dimension. How we do this, how we use vector addition, and how we draw the head to tail diagrams.